given that for all positive integers n, the summation of AR, where R equals to 1 till n, is given by this expression 12 plus 4n squared. We should recall that this symbol is symbol of summation, and you have, let's say here, R equals to 1 till 3 of AR. If you're going to calculate this or to express it, you're going to replace R by 1 plus, because there's a summation symbol, A2, because from 1 you go to 2, and then you reach 3, which is the number above at above the summation, so it's going to be A3. Now in this question they already gave you the expression of the summation. Therefore, if you're going to apply or to find the value of the summation of R, which is equal, where R is equal to 1 till 5, you directly replace this n by 5, and after you replace it, you calculate and find the answer, because it's already given to you as an expression. Now in part B, find the value of A6. Now if we're going to write the summation, or we want to express the summation of AR from 1 till 5, is going to be A1 plus A2 plus A3 plus A4 plus A5. So we express it as the summation of R equals 1 till 5. Now if you want to find the summation of A1 plus A2 plus A3 plus A4 plus A5 plus A6, therefore you are expressing it in this manner. It's R equals 1 till 6. Now they didn't ask us for the value of the summation, they asked us for the value of a certain term in this summation. So therefore this is why to find A6, we subtract the summation of A6 of AR, where R equals to 1 till 6, minus the summation of AR, where R equals 1 till 5, because when you subtract them from each other, you will get this minus that, and A6 would be your value, and this is the value that they want us to find. So this is why you see here summation of R equals 1 till 6 of AR minus the summation of R equals 1 till 5 of AR equals to, you use this formula, where in this place you replace 6 for n, and you already found this value for the summation of R equals 1 till 5 of AR. You add them up, and subtract, so you calculate and you get the answer, which is 44.